Okay, so we have 5 questions, and we're looking for low-hanging fruit to do. And just quickly looking over it, I'm going to say 4 looks like the easiest one for me to do. All right, so 4 looks like the easiest one for me to do. So let me write this down. And what do you get over there? Let's see. I'm going to square the first equation. That's x squared minus 2xy plus y squared equals 121. If I just, do that square in the second equation, it could be x squared plus 2xy plus y squared equals 169. I want to know the value of xy, so I want to get rid of x squared and y squared. So I'll do that by subtracting. So I'll subtract 121 from 169, and that would give you 4xy. It's pretty easy to do. What do you get over here? Let's see, you get 48 equals 4xy, and xy would equal 12. All right, let's take a look at the key and see if they got 12. Yep. All right, let's go back. Let's look for more low-hanging fruit. So I'm going to say 4 is done. I'm going to erase that now. I feel comfortable. And again, I'm trying to pick off the fruit. All right, so 4 wasn't bad. I'm going to say 2 is the next one I'm going to try. Before I do anything, though, I want to point out, I'm hoping your algebra teachers or pre-calculus teachers told you that graphing is a good idea when you're trying to answer questions like this. And this is a range problem. The domain of this is all real numbers, by the way. So I'm looking at this thing. I'm going to say it's 0. The thing would be 1. I'm just doing a real simple graph, by the way. And at -1, it would be 0. I know the function is positive to the right of -1 and negative to the left of -1. And I know it's asymptotic with the x-axis. So I'm going to say maybe something like this over here. And again, this is just a rough picture. I'm not saying it's right. All right, so I looking at it, I got a gut feeling there's going to be a maximum over here and a minimum over here. And if I know that, I know the range. So what I'm going to do is I'm going to use calculus to do it. You could use pre-calculus. I'm going to use calculus. So I'm going to say f prime. And what I'm going to do is I'm going to use the quotient rule. So it's going to be x squared plus 1 squared, x squared plus 1 times 1 minus, if this doesn't prove to be productive, I would go back to the pre-calculus method. Okay, so what do you get now? You're going to get the top, which is x plus 1, times the derivative of the bottom, which is 2x. Well, I got to simplify this now, right? So you get x squared plus 1 squared. On top, you get x squared minus 2x squared, which would be minus x squared. Let me make sure I said that right. X squared minus 2x squared minus x squared. And then you get 1. Yeah, see the 1. I'd also get minus 2x. And I would get 1. Let me just check that. You get 1 plus x squared minus 2x squared minus 2x. So minus x squared minus 2x. Yeah, I think I did okay. And what do I got to do now? I got to get the critical values. And the critical values of this one, when the top becomes 0. The bottom is never 0, by the way. So I think I can handle that. And it's going to be, let's take a look at that. So I'm really trying to solve the top when it's equal to 0. And let me just write this down. So it's really minus x squared minus 2x plus 1 equals 0. I'm going to multiply by minus 1, so it's x squared plus 2x minus 1 equals 0. So x would equal quadratic formula, right? Minus b plus or minus. The b squared is 4 minus 4 a c. So that's going to be plus 4 over twice a, which is 2. Let's keep going. So I can put down minus 2 plus or minus root 8, which is 2 root 2 over 2. And the critical values are going to be minus 1 plus or minus root 2. I'm going to put my analysis down. And two critical values. And what do I get? Minus 1 minus root 2, minus 1 plus root 2. And I'm just going to go back to the derivative and plug numbers in just to make sure my graph is what I expect it to be. Minus 1 plus root 2, a number after that, like, 1,000. Clearly the derivative would be negative. Going down. And if I do a number below minus 1 minus root 2, like minus 1,000, that would also be negative. Looking in the derivative, by the way, I'm analyzing the derivative. And between minus 1 minus root 2 and minus 1 plus root 2, I would pick 0. That's between those two. And you get a positive number. So my minimum value occurs here. This is the min, and this is the max. And I'm glad I got a picture. And my picture's kind of getting you that too, right? So I just got to figure out what those numbers are. And this is a tough part for me. I got to do the work. So I got to do f of root 2 minus 1, and I have to do f of, minus 1 minus root 2. And I got to do that. And someone says, yeah, that's a lot of work. I got to do to get the range, right? Because the range is going to be what's that upper value there. So the top on this one would just be root 2. And the top on this one would be minus root 2. The bottom's a little more difficult, though. I'm going to do that. I'm going to square it. And what do you get? And again, we'll do this one first. This would give me 2 plus 1 minus 2 root 2. And that's going to be what if I did that? I'd have to add 1 to it, right? So 2 plus 1, so it's going to be 4 minus 2 root 2. All right, let me do the next one. And the next one's going to be squaring that number. Well, let's take a look. And I want to make sure you know what I'm doing. I'm doing minus 1 minus root 2 squared like this over here. Yeah, I still get the 1 plus 2, right? And then I get 2 root 2's. And we got to add 1 to that. And what's that going to give you? That's going to give you 4 plus 2 root 2. So the range of this thing, the range, is going to bottom out here. And it's going to top out here. Let's look at the key. What number is that? Number 2, right? Looks like I did a simplification. Let me go back and do that then, okay? And let me take a look at that. So minus root 2, 4 plus 2 root 2. I'm going to factor out 2 on the bottom. And that's going to give me 2 plus root 2, and I get a minus root 2 on top. I can multiply the bottom by its conjugate. So 2 minus root 2, 2 minus root 2, and you're going to get 1/2. And this is going to give you, minus 2 root 2 plus 2. I'm just doing the top, by the way. And on bottom, you're going to get 4 minus 2. They're conjugates, right? So what do you get over here? Let's see, 4 minus 2 is 2. I get a 2 in the bottom. This 2 over here divides into the top, minus root 2 plus 1. Let me go back and take a look at that. That's number 2, right? Yeah, I'm seeing that. I'm seeing the 1 minus root 2 over 2. And let's do the other one, too. All right, let's just check it out, all right? I hate to be pedantic with this, but let's check it out. I'm going to factor out, I'm doing the top now, the upper limit. I'm going to factor out half in that one over there. You get 2 minus root 2. I can multiply the bottom by the conjugate. You might seem pointless, but we'll do it anyway. The top would be, let's see, 2 root 2 plus 2. On the bottom you get 4 minus 2, which is 2. And this would turn out to be 2 root 2 plus 1. Let's just check that. Yeah, I'm doing okay. By the way, they also do it using a pre-calculus method over here. All right? So 2 different ways. I just think the calculus is a little bit easier for me to handle. Right, less thinking. Okay, so I'm going to say I've done 2 already, and I'm going to go back and look. This was a little more involved. The first one I did was really simple, though. It was almost like it's a real confidence builder, and you need to get that. You need to get those done. I'm not going to say every competitive exam has a confidence builder on it. I mean, some are so difficult. You can't answer any of the questions are so difficult. But there's always somebody that answers the questions. I hate to say that. All right, so I'm kind of looking around. That word problem in the end looks kind of crazy, but I'm going to look at number 1. And it says find the sum. And what I'm going to do is I'm just going to write down the partial sums. And I'm hoping to see a pattern. So I'm seeing, I kind of see a pattern in the problem now, like 1, 2, 3, 4. I could definitely predict the next term is 5. And if I look at the bottom, they just look like factorials to me, all right? I'm not saying it's a wrong way to go, but, certainly that's a lot of work. I mean, it's certainly related to functions that you may know about, or factorials in the bottom. But that top part's the tough part for me, right? So I'm just going to write down partial sums. But the bottoms look like factorials, and the tops are just like, an arithmetic 1, 2, 3, 4, 5, 6. Let's write down S1. And what's S1 going to be? That's the first partial sum, which is 1/2. Let's write down S2, and that's going to be 1/2 plus 2/6. And let's see, that would be 1/2 plus 1/3. That would be 6. And you get 3 plus 2, which is 5. All right, that's not so bad. Let's put down S3. And that's going to be 5/6 plus 3/24. Well, you're going to get 24 as a denominator. And then you're going to get, let's see, 4 times 5 is 23. Well, there's a pattern. I'm not sure if it's going to keep going, but let's take a look. S4, what's that going to be? Let's see, 23/24 plus 4 over 120. And I'm going to say that's 120. And 5 times 23, because 5 times 24 is 120. 5 times 23 is 115, so 119. So I'm definitely seeing the pattern. And someone says, what pattern are you seeing? Well, I saw it kind of before. I'm seeing factorials. Like 2 factorial, 3 factorial, 4 factorial, 5 factorial. And then what am I seeing on top? I'm seeing the top is 1 less than the bottom every single time. So I'm going to write down that Sn, the nth partial sum, is going to be, well, let's take a look. Now remember what I said. This is 4, and this was 5 factorial. This was 3, that's 4 factorial. 2, 3 factorial. 1, 2 factorial. Well, let me write this down then. So what would this be? N plus 1 factorial. What goes on top? N plus 1 factorial minus 1. Well, if you simplify this, what do you get? You would get 1 minus 1 over n plus 1 factorial. All right? Now, I want to find out what s is, though. And what's s going to be? It's going to be the limit as n goes to infinity of Sn. And what do you get over here? Well, looking at this thing, I'm looking at this over here. The limit of that's pretty simple, just 1. So the sum is 1. All right? So, I didn't really spend much time at that. I guess I could look for something else, but I want to go to the key. I want to point out, I really think a better way of doing it is to, recognize what the pattern is. All right? So I would say this is a better way of doing it, recognizing the pattern, and recognizing it's something to do with e to the x. And certainly I write that stuff down for you. There's trouble here, though, and I want to point out what the trouble is. It's getting it to look like what it is, right? It really is an e to the x, and I keep writing things down, differentiating, putting things together, yada, 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 but I eventually get it. I eventually get it. But I also did it by partial sums. I thought the partial sum is less elegant, but it does work out nicely, you know, provided things are nice. And these are nice problems, all right? So the sum is going to be 1. All right, let me get my eraser out. Erase this business over here. And I've done some of the problems already. So what have we done so far? We've done 1. We've done 2. I've done 4. And now I am going to go to 3. It says, let n be the smallest integer such that the sum of the digits of the sum of the digits of n is 11. Wow. So I'm going to have a number n. I'm going to have another number over here. And then the sum of these digits over here would be 11. By the way, there are, I'm looking for the smallest number though, right? So the only way to achieve this over here is if I have a 2-digit number now. And how can I get it to add up to 11? There's many ways to do it. I mean, I guess I could try 2 and 9. I could try 9 and 2. You get the idea? What else could I try? 3 and 8, or 8 and 3. I think you get the idea, right? 4 and 7, or 7 and 4. Again, these 2 digits was up to 11. And I guess I could do 5 and 6 too, right? And 6 and 5. All right. Let's start thinking about it. Again, it says, let n be the smallest integer such as the sum of the digits of n is 11. Let's take a really careful look. And I'm going to go for the smallest number now, 29. Now I got to think. And I'm going to erase this over here, my thinking there. I need to think backwards, right? So could I have a 3-digit number here? No, because whatever I do, 9, 9, 9, right? That wouldn't give me, there's no way I get 29 with 3-digit numbers. It's got to be a 4-digit number. So n is a 4-digit number. So 4 digits. Well, let me think. I could try 9, 9, 9, and 2. You know, I'm really trying to get this to be as small as possible, right? And I'm going to write this as 2, 9, 9, 9. Let me erase this up here. All right, let me take a look at it. I'm claiming that's the number. That's the smallest number I could find where the sum of those digits, 9 plus 9 plus 9 is 27, 29, would give me the 29. And the sum of 29 would give me the 11. All right? By the way, I'm going to go back and read it. It says, let n be the smallest integer such that the sum of the digits of the sum of the digits is 11. Now, I think I accomplished that. All right, I think I accomplished this. All right. What's our question now? What is the sum of the digits what is the sum of the digits of the sum of the digits of n plus 1? Well, I'm claiming this is n. So n plus 1 would be 3,000. So the sum of the digits of n plus 1 would just be the number 3. All right, let's take a look. This is problem number 3. Let's see what they did. And let's see, the sum of the digits n will be 29. The smallest number whose sum of the digits 11 is 2 plus 9. And so n is 2999. I think I wrote that down. The smallest number whose digits sum to 29. N plus 1 is 3,000. By the way, I forgot to write down the answer is 3. All right, the sum of those digits is 3. All right, just forgot to write it down. Happens sometimes. I think we did okay. All right, let me get my eraser out. I'm going to go to 5. 5's the only one I haven't answered yet. So it says a 12-inch ruler has tick marks at every... By the way, if you're from the United States, this is a familiar object. We have really weird numbering systems, I'll tell you, even for rulers. It's just crazy looking. But anyway, it's what we do. And this might look strange to you. But it says a 12-inch ruler has tick marks every 16th of an inch. I see that. You know, nice little picture over there. Including at the beginning and the end. It has tick marks which are 5/10 of an inch long. So I'm going to just make sure you understand that that the beginning and the end of this unit interval, that the lengths of these things over here are 5/10. All right? Now, it also goes on to say, I got to be careful when I'm reading this over here. It says, they're 5/10 inch long. At each half-inch tick mark, it's 4/10. So this over here is 4/10. All right, you got to keep going. Right? At each quarter-inch, tick marks are 3/10. The quarter-inch, it's 3/10. All right, let's keep going. At the 1/8 inch, it's 2/10. All right? At each 16th, the tick mark is only 1/10. These are these small guys over here. Let me go back to black, the small ones. They're just 1/10. All right, now, by the way, I'm starting to realize I didn't put a question here. I would say, the question over here should be, what's the sum of all lengths of the tick marks on a 12-inch ruler? Well, I'm going to do what's on the inside first. And there's going to be 12 of these on a 12-inch ruler. And what would I get? Now, I'm going to do this one first. There's 1, 2, 3, 4, 5, 6, 7, 8. 8/10. All right, I'm going to do the yellow guys next. There's 1, 2, I forgot to do that one over, 3, 4. That's yellow. I'm sorry about that. There's 4 of those yellow guys. That's 8/10. This is done. Now let's go to the green ones. There's 1, 2. Well, 2 of these guys were 6/10. And did I account for everything? No, I didn't account for this. And that's just going to be, there's only 1 of those, right? All right, and these are all in inches, by the way. I got to do the arithmetic now, right? 12. And let's see, you get 8 and 8. That's 16. And 10, 26 tenths. I gotta be careful here, right? So I'm gonna just do 12, and this would be 13/5. And 12 times 13, well, that's gonna be 120, because 10 times 12 is 120, and 36, because 3 times 12 is 36. So 156 over 5. But I got to do these guys over here. Now, on a 12-inch ruler, how many are there going to be? There's going to be 13 of those. 13 of those, and those are worth 5/10. And what's that going to give you? Well, 65/10. All right, I got to do something now. I got to do 65/10 plus, well, I got to get tenths in that other guy, right? I'm adding this on. So these two have to be added together. And let's hope I didn't make any mistakes in the counting. Let's see, that would be 312, right? And that would be, let's see, 377/10, which is going to be, let's put this down. This is going to be 37.7. Well, since they're speaking in fractions, I guess I got to continue, right? So let's continue to write that down as a fraction. So it's going to be 37 and 7/10 of an inch. All right, again, I'll revise the question, because there is no question. But let's see if I got it right. Yeah, right over here. All right, so we did it right. So my claim over here is just going back over the questions again. Let me just make sure I understand what I did over here. I mean, really, the easiest one to do. I really believe this was the easiest one to do. I believe the next easy one was 2. I believe if I was doing partial sums, that wasn't so bad. This one here, a little bit confusing to me, to be honest with you. But I got to be honest with you, even though there's a lot of words in this thing, and I missed the question, there was no question over there, it wasn't that bad. It was just looking at a picture and kind of determining. What was confusing for a lot of students, though, is realizing that there'd be 13 of these long ones over here. And that's usually what's called a one-off principle. Like, people are one-off in a lot of things. Well, they know how to count, but they're one-off when they're counting. Okay, so the deal is this. If you need to reach out to me, my email address is Bannon, that's B as in boy, ANNON.US. And if I'm not overwhelmed with emails, I'll respond to you. But again, if I get overwhelmed, I won't be able to respond to you. But if you have a better idea, or you have a comment about, you did something wrong, I don't mind adding it to my notes, by the way. I mean, if it's something productive, you're saying, that's not true what you said or what you wrote down, there's a subtle problem with it, I got a better answer, I got a better method, yeah, please write. I might update the notes. But at this point in time, the only people that have access to this document are the people involved in the prison mathematics project. All right? Now, the documents I share with them, some of them are kind of long. This is a 300-page document, but I'm actually sharing them, other documents with them that are like in the thousands of pages, and it's to give people an opportunity to work problems, and I do believe working problems is an activity that is helpful to everyone who works problems. It's helpful to do that, but again, if you feel like you need to reach out to me, please do so. I really do appreciate you paying attention. Thank you.